Welcome back. In this lesson, we're going to start looking at the atmosphere. And the atmosphere, of course, is made out of gases that extend from the Earth's surface up to space. So it's like a big blanket of gases surrounding the Earth. Those gases will not only just help you breathe, they're useful for numerous things. Life on Earth could not exist without our atmosphere. It regulates our temperature. It protects us in many ways from radiation from space. We'll look at this in detail. So we'll look at the layers of the atmosphere, the components of the atmosphere, and how heat is transferred in the atmosphere. So let's look at some details. So the first thing that we talk about is the composition of the atmosphere. What is the atmosphere made up of? The atmosphere is mostly gases. And of the gases that make up the atmosphere, most of it is going to be nitrogen gas. About 78% of the atmosphere's composition is nitrogen. Nitrogen is considered inert, meaning it really doesn't do anything to you when you breathe it. It's not poisonous to you, and it's not helpful to you. It's not what your body needs. In order to break down food into energy and take away the poisons from your blood, your body needs oxygen to do that. And so oxygen is about 20%, 21% of the atmosphere. Those are the permanent gases. You're going to have just a little bit of other stuff, trace amounts of gases other than nitrogen and oxygen. The variable gases are going to be things, of course, that change. You have more or less on any given time. So water vapor in the air, what we call weather, is essentially an increase and decrease in water vapor along with temperature. So depending upon what type of air mass that you're talking about, whether it comes together over a continent, which it's usually drier, or over the ocean, which is usually wetter, and then whether it's over the poles or over the tropics, will be the temperature difference. So all of that is what we'll study when we'll talk about weather. Carbon dioxide is also variable. Carbon dioxide changes. Of course, you breathe out, and all animals breathe out carbon dioxide and take in oxygen. Plants are the other way. Plants will take in carbon dioxide, absorb carbon dioxide, and then expel oxygen. Green plants will do that. So the other variable gas is very high in the atmosphere, and that's called ozone. And ozone is 3 oxygen molecules linked together. There's a layer of ozone, it's from about 6 to 25 miles in the air, so about a quarter of a way up through the atmosphere. The atmosphere is about 100 miles high. So in that place, there is a large layer of ozone molecules. And it has a very serious function in terms of protecting us. It will shield or deflect most of the ultraviolet radiation from the sun. And UV radiation will give you a nice suntan, but it could also give you skin cancer and burn you. So it is a filter, basically a large layer like a sunglasses that the Earth has, so that living here is not so dangerous. Lastly, there's particles in the air. There's salts in the air. There's dust in the air. There's ice in the air. A lot of times what you're seeing when you see clouds is liquid water and frozen water in the sky. And then also there's, along with the dust, there's also microorganisms. There's viruses, bacteria. These things are small enough to be airborne. That's why everyone wears a mask these days. So to protect you from what is floating in the air that is expelled when people speak. So that can be in the air too. So salts, really, really fine particles, can get in your lungs. Dust can get in your lungs. Smoke can get in your lungs. So these are all particulate matter. So let's first look at the atmospheric layers. So if you were to go from the surface of the Earth up into space, roughly 600 miles, you would have gases. Now, most of those gases are going to be within 100 miles of the surface. So the denser the gases would be closer to the ground, and then the less dense as it goes higher. In terms of absolutely nothing at all, where it's empty space, you could consider it into the even thousands of miles away from Earth, to where that there's nothing that the Earth's gravity is affecting. But when you're considering the atmosphere, mostly the atmosphere is going to be about from 100 to 600 miles of gases high above you. So these layers all have names. The first one is closest to the Earth. It's up to about 9 miles high, and that's called the troposphere. Most of the weather occurs in the troposphere. It's where the gases are most dense. Above the troposphere is the stratosphere. And the stratosphere, there's really no weather happening. Most of the airplanes are flying lower than that. You might have some weather balloons in the stratosphere measuring things. But one of the things that's in the stratosphere is the ozone layer. And the ozone, remember that O3 molecule, there's a layer of those, so it's very, very light, ozone is, and it goes all the way high, so it doesn't stay close to the Earth. It goes all the way up into the stratosphere and acts as a layer, as a filter, filtering the Earth from UV light. So ultraviolet radiation can give you a suntan, but it can also cause skin cancer, and we do not want all the radiation that the sun has to give us. So most of it is going to be filtered through the ozone. By the time you get to the top of the stratosphere, nearly 100% of the gases are below that line. So even though you have higher levels, almost all the gas goes up to about 100 miles, something like that. Now the mesosphere is the next. The meso means middle, so the middle of the 5, and the mesosphere is where you'll see the meteors burning up. So falling stars, shooting stars, they burn up in the mesosphere. Above the mesosphere is the thermosphere, and thermosphere, one of the things you'd know for the thermosphere is where the auroras are. So the northern lights, the southern lights, that would happen in the thermosphere. Also, most of the satellites would be in the thermosphere. You may have some, maybe the space station or something a little higher, but most of the communication GPS type satellites are in the thermosphere. Above the thermosphere, so about 350, 375 miles, up to whatever, 6,000 miles, that's really basically empty space, but it's the very final layer of the atmosphere called the exosphere. Exo meaning exit. It's where you're going out of the atmosphere. But there is some stuff there, but very, very little. And you'll see that's where the space station is, for instance. So the one more I want to mention is not based on altitude, but there is something called the ionosphere. It's kind of embedded in between the thermosphere, exosphere, and there's charged particles there, ions, electrons there. And one of the things that it can do is bounce electric or radio waves off. So if you have a radio station, or you have a tower for cell phones or whatever like that, it can actually bounce those waves off of this layer of charged particles and go from basically a shortcut, bouncing off of the atmosphere, coming back to a farther tower way far away. On really stormy nights, people that have ham radios or shortwave radios can actually pick up very far away stations like Russia and China, just radio stations, because they're bouncing off of this layer. The next is the energy transfer. So the sun is burping out all kinds of electromagnetic radiation, from radio waves, X-rays, gamma rays, light, heat, all of this. And it can go straight through empty space. This is called radiation. Now radiation can take that energy, say light energy or heat energy, and it can make it all the way to the Earth's surface. So if you were to have that energy, it could be absorbed by the ground, by the material, the solids that are on the ground, and then once they're warmed, it could warm, say, the air above it. So once radiation can take that energy and transfer it, it can then be conducted. Remember, conduction is when one warm object loses some of its heat to a cooler object. So for instance, the ground that's warm can heat the air above it, and then that air can move around, And that was what we'll see later is causing weather. So, so you have radiation, conduction, and then the last one we're going to look at is convection. So we've talked about radiation, which travels straight through electromagnetic waves, and conduction, where something touching something else can transfer heat. And then the last is called convection. And convection is when there's kind of a circle, kind of a circuit, as heated air will rise because it becomes less dense. And then as it cools, it's going to sink. And so it will kind of create what we'll later see as weather patterns. As the heat difference on the surface of the Earth is different in different places, it creates currents in the atmosphere. So these gases are actually moving, and then that will cause weather.